Namaste everyone, welcome to the class again. Now let us see this 20th question. The 20th question is a power minus 1 plus b power minus 1 whole divided by a power minus 2 minus b power minus 2. Okay, so this a power minus 1 I can write a power minus 1 can be written as 1 upon a plus b power minus 1 can be written as 1 upon b, and this whole divided by, here we have 1 upon a square minus we have 1 upon b square. This much is clear to you all. A power minus 1 means 1 upon a, and similarly a power minus 2 means 1 upon a square. This is rule of indices. Okay, you have to remember this. Now here you can cross multiply. What you can say, that 1 into b, it is b, plus 1 into a, it is a, whole divided by a into b. Okay, this also you know how to add two fraction numbers, and here it is b square minus a square whole divided by a square into b square. Now this a is equals to a plus b whole divided by ab. Now this division will convert in multiplication and we reciprocate it, so it become a square into b square whole divided by b square minus a square. Okay, so this is equals to a plus b. Now this a will cancel with this a square, so here we get a and this b will also cancel. So now we have a plus b into, now there is nothing in denominator, and here we have a into b whole divided by, now this b square minus a square I will write as b minus a into b plus a. Now this b plus a and this a plus b, they are same thing. We say b plus a or a plus b, so you can cancel this and your final result is a into b divided by b minus a. So this is your simplification of this question. Now one more question is there. It is always better that you try to solve the problems, okay, even if you do some mistake, but you will learn a lot. So 1 upon, now this is 1 plus a power m minus n. Now a power m minus n means a power m divided by a power n. Again you know this rule, a power m upon a power n is a power m minus n. So this a power m minus n I can write like this. Then we have plus sign 1 upon, here it is 1 plus, now I will write here a power n divided by a power m. So this is equals to 1 upon, now here I will cross multiply, so I will get a power n plus a power m whole divided by a power n, plus here I have 1 upon, this is a power m plus a power n whole divided by a power m. So this is equals to, here I have a power n divided by a power n plus a power m, plus now here I have a power m will go up, and in denominator I have a power m plus a power n, so I can write this as a power n plus a power m. Okay, we can switch the position, 2 plus 3 we can write 3 plus 2. So now denominator is same, so we add numerator, as denominator is same, if there is plus sign we add numerator. So our numerator is a power n plus a power m, and our denominator is also a power n plus a power m. So numerator and denominator same, so therefore they will cancel and I will get answer as 1. So this is question number 20. Now let us see question number 21. We have to prove the following. Okay, prove the following. So we know what answer we should get. Okay, so this first question, we will start with left hand side, right? Okay, so your LHS left hand side, your LHS is a plus b the whole power minus 1 into, it is a power minus 1 plus b power minus 1. Now this a plus b the whole power minus 1 will be 1 upon a plus b into, here I have 1 upon a plus 1 upon b. So this I will say that this is 1 upon a plus b into, here we can cross multiply and we will say that this is b plus a whole divided by a plus b. Sorry, not a plus b, it is a into b. Denominator is multiplied. So this is a into b. Now this a plus b and this b plus a or a plus b, you can say they cancel and we will get 1 upon ab. So we got right hand side. So hence my LHS is equals to RHS. LHS is equals to RHS means this a plus b the whole power minus 1 into a power minus 1 plus b power minus 1 is equals to 1 upon ab. Okay, one more question. What happened? Second question. Okay. Okay. Acha, here what we need to prove I haven't written. So this complete question is incomplete. Let me check. Okay, this second question is x plus y plus z upon x power minus 1, y power minus 1 plus y power minus 1, z power minus 1 plus z power minus 1, x power minus 1 is equals to x, y, z. Okay, so let us prove this. So here we write first question. Now LHS, it is simple. You use the property which you know for exponent and definitely you will get the answer. Now this is x plus y plus z. Denominator is x power minus 1, y power minus 1 plus y power minus 1, z power minus 1 plus z power minus 1, x power minus 1. So this is equals to, I have x plus y plus z upon this I will write 1 upon xy plus this I will write 1 upon yz plus this I will write 1 upon zx. This is 1 upon zx. Now x plus y plus z, this is in numerator, x plus y plus z, and my denominator here I cannot add them till their denominator is same. So I will take the LCM of this xy, yz and zx, which is xyz. So here in first term I will multiply by z and divide by z. So this will become z upon xyz. The second term will become x upon xyz and the third term will become y upon xyz. So I will write this as z plus x plus y upon xyz. So one step we have reduced, okay, by taking LCM. If you want, you can write that step. Now here it is x plus y plus z, and then we have divide by x plus y plus z upon xyz. So this will become x plus y plus z. This division will convert in multiplication, and here we have xyz divided by x plus y plus z. So this x plus y plus z and this x plus y plus z will cancel, and here I will get answer as XYZ, which is our right hand side. So LHS is equals to RHS. LHS is x plus y plus z upon x power minus 1, y power minus 1 plus y power minus 1, z power minus 1 plus z power minus 1, x power minus 1 will be equals to XYZ. So second part of this 21st question. Now let us see this 22nd question. If A equal to, again something is incomplete, so let me check again. Okay, so here we have to prove that if A is equal to C power Z, B equal to A power X and C is equal to B power Y, then we have to prove that X, Y, Z is equal to 1. This is our 22nd question. Okay, we have to prove that this X, Y, Z is equal to 1. So what we do? A is equal to C power Z and C is equal to B power Y and B is equal to A power X. So what we will do? Confusing, right? No worry. We have to find the value of XYZ. XYZ is equal to 1. So how to get XYZ? Okay, let us start with A. Now A is equal to C power Z. Now this C power Z, I will write this as equal to, what is the value of C? It is B power Y. So this is B power Y, the whole power Z is equal to B power YZ. So A is equal to B power YZ. Now this B is again A power X. So this B will be written as A power X, the whole power YZ. So this become A power XYZ. Now A is equal to A power XYZ. A is equal to A power XYZ. Here A means A power 1. So A power 1 is equal to A power XYZ. So this indicates that 1 is equal to XYZ, or I will say that XYZ is equal to 1. So the value of XYZ is 1. XYZ is equal to 1. This is 22nd question. 23rd question is again the same kind of question but little different. These questions can be solved in different ways by different teachers. So all the ways are right till we are using proper mathematical formulas. Now here A is given x into y power p minus 1, B is equals to x into y power q minus 1 and C is equals to x into y power r minus 1. Then we have to prove that A power q minus r into B power r minus p into C power p minus q is equal to 1. Oh. So what we will do? Again a challenging question. So let us define what is A power q minus r. Now A power q minus r is x into y power p minus 1 the whole power q minus r. So this will be x power q minus r into y power, now they will multiply, so p minus 1 into q minus r, so it is pq minus pr minus q plus r. This is A power q minus r. Similarly, we will find B power r minus p. So B power r minus p is equals to, what is the value of B? It is x y power q minus 1 the whole power r minus p. So this will become x power r minus p into y power qr minus qp minus r plus p. This is, I will say, first equation. This I will say second equation. And similarly we have c power p minus q. So c power p minus q will be x into y power what is c, r minus 1, the whole power p minus q. So this will become x power p minus q into y power, this is pr minus qr minus p plus q. This is third equation. Now we multiply this equation 1, 2 and 3 because here we have to prove that a power q minus r into b power r minus p into c power p minus q is equals to 1. So here I will say that multiply equation 1, 2 and 3. So when we multiply on left hand side we will get a power q minus r, a power q minus r into b power r minus p into c power p minus q. And on right hand side we have x power q minus r, we have x power q minus r. So actually I will copy and paste. This value is a power q minus r into we have b power r minus p. So this is into b power r minus p into here the third term I will write, this is my third term. Okay, these all three are in multiplication, right? So here also I will use into multiplication. This multiplied by this multiplied by this. So we have to multiply all these three terms. So here I will write x first. So this is x power. Now here we have q minus r into x power, here I have r minus p into x power, here I have p minus q into now y power. So here we have y power pq minus pr minus q plus r into we have y power qr minus qp minus r plus p into we have y power pr minus qr minus p plus q. So this will become, this is equals to x power, here as the base is same I will add the powers. So here it will become x power q minus r plus r minus p plus p minus q into y power. Now here I have pq minus pr minus q plus r plus qr minus qp minus r plus p plus pr minus qr minus p plus q. So this is equals to x power. Now this q and this minus q, they will cancel. So this q and q will cancel. This minus r and this plus r will cancel, and this minus p plus p will cancel. So we have x power 0 into y power. Now for y power we can see that this is pq and we must have minus pq also. So this is minus pq. We have minus pr, so we must have plus pr. Here it is plus pr, and this plus qr and minus qr, they cancel, and similarly minus q will cancel with plus q, minus p will cancel with plus p, and minus r will cancel with plus r. So y power 0. X power 0 is 1, y power 0 is 1, 1 into 1 is 1. So this is how we prove it. This is our right hand side. So what is asked? We have to prove that a power q minus r into b power r minus p into c power p minus q is equals to 1. So as we are going further, the problems are getting little difficult. Yes. Now let us see this 24th question. Twenty-fourth question is 2 power x is equals to 3 power y equal to 6 power minus z. We have to prove that 1 upon x plus 1 upon y plus 1 upon z is equals to 0. Okay. So let me try a different approach. Okay. Here 2 power x is equal to 3 power y, and this is equals to 6 power z. I think this is z. Let us cross verify that it is plus z or minus z. 24th question. Here it is minus z. Okay, fine, no problem, minus z. Let us see. I will say that let this is equals to k. Okay, so that will give me a method to find the value of x. So here what I can say that, so therefore I can say that 2 power x is equals to k. 2 power x is equals to k. Therefore what we can say about x, we can say that 2 is equals to x power k power 1 upon x. We can say that this is 2 is equals to k power 1 upon x, but that will not help me. 2 into 3 is 6. One thing is that 2 into 3 is 6. Okay, fine. Okay, so this 2 is k power, I will say that 2 is equals to k power 1 upon x. Okay, when 2 power x is k, so k is equals to k power 1 upon x. This is again the rule of indices. You should remember, when we take xth root, this is called xth root. When I take xth root on both the sides, so here it will become 2 power x into 1 upon x, so that x and 1 upon x cancel, and here it is k power 1 upon x. Okay, similarly 3 power y is equals to k. This implies 3 is equals to k power 1 upon y, and z power minus 6 power minus z, 6 power minus z is equals to k. This will give you, or this will indicate that 6 is equals to k power 1 upon minus z. So here I will say this is equation 1, this is equation 2, and this is equation 3. We know that there is a relation between 2, 3 and 6 as 2 into 3 is equals to 6. So therefore from 1, 2 and 3, so from 1, 2 and 3, what I will say that 2 in place of 2 I will say k power 1 upon x. Therefore k power 1 upon x into k power 1 upon y is equals to k power 1 upon minus z. Okay, this much is okay. So here as base is same, I will say that therefore k power 1 upon x plus 1 upon y is equals to, here I will say that k power 1 upon minus z, that is minus 1 upon z I will say. So now this k I can cancel, so therefore I have 1 upon x plus 1 upon y is equals to minus 1 upon z. So therefore I can say that therefore 1 upon x plus 1 upon y plus 1 upon z is equals to, now this will come on left hand side and here I will get 0. So 1 upon x plus 1 upon y plus 1 upon z is equals to 0. Hence we have proved, right? Okay. So let us stop our lecture here. In the next class we will see few more questions like this. Thank you.